So imagine holding a standard, a black video cable in your hand. Now imagine someone telling you it costs $740.
Yeah, I mean, your first question is probably, does it plug into a spaceship or something?
Exactly. Well, welcome to today's deep dive. Today's mission is to unpack this highly specific product page for the DVIGear DVI-2375 AOC-M active optical cable.
Which is quite a mouthful.
It is. And it's a 75-meter cord, so roughly 250 feet. But that massive price tag is actually a window into the extreme, almost absurd engineering required for professional AV setups. Okay, let's unpack this.
Well, the first thing you have to realize is that pushing high-resolution video over long distances it's incredibly difficult. If you try to run a standard copper cable 250 feet through a building, the electrical signal just degrades into complete mush.
Oh, wow. Which explains why I can't just grab like a $20 cord online to wire up a massive auditorium. So how does this cable actually pull it off?
It abandons pure copper. This isn't a standard wire at all. It's an active optical cable, or AOC, using something they call hyperlight technology.
So it's essentially a hybrid, right?
Yeah, exactly.
Yeah.
Inside that incredibly thin black jacket, you have 4 polyfluorinated optical fibers running right alongside 6 traditional copper members. And together, they are pushing 4.95 gigabits per second of total bandwidth.
Which is massive. I mean, think of this hybrid structure like a highly specialized transit system. The optical fibers are the high-speed bullet trains instantly moving heavy video data up to 1920 by 1200 resolution. And the copper wires are like the local roads handling basic communications.
Right, like EDI and HDCP, which basically let the monitor and the computer verify each other's identity so nobody gets confused.
Exactly. But what about the optical fibers?
But what's fascinating here is the optical tech at the ends of the cable. The plugs themselves are miniature data conversion plans. On the sending side, you have multi-mode VCSEL transmitters.
VCSEL transmitters.
Yeah, vertical cavity surface emitting lasers. They literally take the electrical video data and convert it into light at 10 gigahertz.
Wait, that is insane. Tiny lasers inside the plug.
Oh, yeah. And then on the receiving end, you have components made of gallium arsenide, specifically PIN photodiodes. These act like tiny lightning-fast light catchers, instantly converting those laser beams back into an electrical signal the monitor can understand.
Wait, hold on a second. You're saying we have tiny lasers and fragile glass fibers crammed into a cord that has to be dragged through 250 feet of commercial ceilings. How does it not just snap in half the second and installer yanks it around a sharp corner?
That is exactly where the mechanical engineering has to match the data engineering. The physical environment of a commercial building is brutal. I mean, you are threading this through tight, crowded ceiling grids packed with electrical noise.
Right, from HVAC systems and other cables and stuff.
Exactly. And that noise causes electromagnetic dispersion, which can completely ruin a clean video signal. So they feature non-detachable shielded metal enclosures to block RFI and EMI interference. Plus, the cable itself boasts a crush resistance of over 500 newtons.
Okay, but here's the contradiction I don't really get. It's built like an absolute tank to survive 500 newtons of force, yet it maintains this tiny, flexible profile. It's only like 5.1 by 2.9 millimeters. Why does it need to be so rugged yet so thin?
Well, it has to be tiny to navigate those complicated commercial infrastructures without catching. And it's plenum rated, meaning it's safe for building air ducts. But the truly brilliant mechanism here is how it handles power.
Oh, right, because pushing data that far usually requires external power, right?
Yeah, usually you'd need massive signal boosters, which means wall plugs. But because this cable converts the heavy data to light, the whole system draws less than 0.3 watts of power. It's powered entirely by the DVI source.
Wait, really? No wall plug required at all?
None. You don't have to hire an electrician to install an AC adapter up in a drop ceiling. The ultra-low power draw and high immunity mean you just plug it in and it works.
That is incredible. So the next time you, our listener, are sitting in a conference room and you see a flawless, lag-free image on a remote display monitor, you'll appreciate it a little more. You are likely looking at the result of a hidden, hybrid infrastructure of discrete optical channels doing the heavy lifting entirely behind the walls.
Yeah, the best infrastructure is always invisible.
Yeah.
The heavy lifting is done silently and flawlessly.
Absolutely. Which leaves you with this final thought to mull over. If we are engineering self-powered, laser-driven, hybrid, fiber optic cables to stretch supposedly legacy DVI video signals across hundreds of feet of building ductwork, what other supposedly obsolete technologies are secretly being supercharged to run the world around us?